math students. Today we're going to continue talking about relations and functions. So yesterday we talked about a relation is just anything that pairs up inputs with outputs. A lot of times that looks like ordered pairs, but we also did a lot of work yesterday with mapping diagrams. And those arrows kind of make it pretty obvious if we've got a function or not. But we don't always see our information in just ordered pairs and mapping diagrams. I've got some vocabulary that I want to go through that you might want to make some notes on. A relation, we talked about that yesterday again, inputs and outputs, so that's like ordered pairs. A function is a specific kind of relation. So you could have anything that's a relation basically, as long as you can write ordered pairs. But each input can only have one output. That's what makes it a function. The domain is what we talk about for all of the inputs. Typically, we're using x's for the inputs, and the range is all of the outputs, and those are the y's. Okay. The independent variable, and I think that this gets used more so in science than we use right now in math, but independent variables are the inputs also. A lot of times in experiments, for example, in science, the independent variable is going to be time, because the time just keeps on going no matter what. And it can be anything you want to put in there. But again, those are the inputs. Those are x's. Notice I'm even color coordinating here for you, so I'm hoping that that helps. The dependent variable, that's again the outputs. That's the y's. Okay, so when we talk about the domain or the independent variables, same thing, those are the x's. The range, the dependent variable, those are the y's, okay? So if I give you this, instead of a mapping diagram, I've got a table right now, but I've got x's and y's. They are really ordered pairs that I could write, right? The first order pair would be 0, 8, and the next one would be 1, 8, and 2, 8, and 3, 8, and 4, 8. In a mapping diagram, I wouldn't have to rewrite the 8 every time. I could just have used one arrow from each of the input numbers to go to that. But I want you to notice that none of the input numbers repeat. Each input has exactly one output. They all happen to be the same output, but that does not matter. If my x's don't repeat, this is good. This is a function. Because each input has one output. And the second problem. Again, I've got all the same numbers, right? But this time I flip-flopped, and all of my inputs are x's. So that means that I used an 8 for an input right here, and I got a 0 for an output. So I would have an arrow going to the 0, and then I used another 8, and I got a 1, and then I used another 8, and I got a 2. So all of my inputs are the same, but I've got all these different outputs. So this is definitely no, it's not a function. If I did this as a mapping diagram, my inputs I wouldn't have to write 8 all of those times. I would just have 8 for my input, and I would have 0, 1, 2, 3, 4, and I would have an arrow going to the 0 and an arrow going to the 1 and to the 2 and to the 3 and to the 4. And I didn't even do anything this much yesterday. I just had like 2 lines going away from it sometimes. This is clearly not a function because an input has more than one output. Okay, letter C, back to a mapping diagram. Is this a function or not? Take a second, think about it. I'm going to go with no, because 3 as an input has 2 different outputs. I'm not going to keep writing that every time, but one of the inputs has more than one output. That's why it's a no. Letter D is a little bit different to see it as a graph, and I'll show you in just a couple minutes a really nice, easy way to check this. But if I'm looking at this, remember the x's are the inputs, or the independent variables. So if each x value only has one y value that's paired up with it, like this input of 1 only has this point right here that's lined up with it, it's fine. However, 3 right here lines up with a 4, and it lines up with a 5. So no, that is not a function. For letter E, looking at this in a list of ordered pairs. If you really like mapping diagrams like we used yesterday, feel free to make a mapping diagram. I don't usually bother making those though. I'm just going to look at the x's. As long as my x's don't repeat, we're good. So my x's are -2, -1, 0, 1, 2. No repeats? Yes, this is a function. Each input has one output. So again, looking at this list of ordered pairs, my inputs, -2, -1. Ooh, another -1. Nope, I don't even have to go any farther than that. So here's that nice fast way to look at a graph and know if it's a function or not. It's called the vertical line test, and we use this. I kind of already showed you this on that last graph that we looked at. If I can draw a vertical line anywhere on a graph and it hits something that I've graphed more than once, it's not a function. So in the first example, it says it is a function with that dotted line. It hit one of the points. I could even say, well, I'm going to draw a dotted line right here, and it's not even going to hit anything. That's okay to not hit anything, but I can only hit stuff once. So this is a function because it passes the vertical line test. The second one says not a function, it's because it fails the vertical line test. And that vertical line test again means I'm going to draw this vertical line up and down, and it's going to hit right here, and it's going to hit right there. That means that whatever this x value is right here, I had a y value right here, and I had another y value right there. So that's why it fails the vertical line test. So this is just kind of a mishmash of all of our different stuff, deciding if this is a function or not. So again, please look at the inputs. If the inputs don't repeat, we're fine. However, in number 1, the inputs does repeat. So no, it's not a function because one of the inputs has more than one output. Here, at an ordered pair, or in a list of ordered pairs, 0, 1, 2, 3, no x's repeat. Yes, this is a function. Each input has exactly one output. Number 3, does this pass or fail the vertical line test? Well, there's a lot of places where I could draw a line, not hit anything. There's a lot of places I could draw a line, hit one point. However, if I draw my vertical line right here, off a little bit, but right there and right there, hits both of those, this one fails. This is, no, it's not a function. It fails the vertical line test. Number 4, I know this is not linear. I know it's not a straight line. However, if I would draw a vertical line, I can only hit in one place. Now, I could do that multiple times, but each vertical line will only touch the graph once. So, yes, this is a function. Today's worksheet is going to have problems that look like this. One side of the worksheet is just deciding function or not a function. Does it pass the vertical line test or does it fail the vertical line test? So for number 4 right here, the issue that I have with this graph is if I draw my vertical line, oh my goodness, I am struggling with my alignment and my straight lines myself. Right here it hits and right here it hits. Not a function. For number 5, no matter where I would draw a vertical line, it would only hit one time. Yes, that is a function. Number 6, we already looked at a shape like this. This shape is called a parabola, by the way. No matter where I draw a vertical line, I would only get 1 point, so that is a function. Number 7, if I would draw my vertical line somewhere over here, it's going to hit here and here, not a function. For number 8, this is basically the same shape, right? It's another V shape. However, because of the way that it's turned, I only hit one time, no matter where I draw that. So yes, that one, was bad X, is a function. And for my last one, I know it's a triangle. However, if I draw a vertical line, I can hit more than once. That is not a function. It fails the vertical line test. So 1/2 of your worksheet today should be super easy. Yes or no, is a function or is not a function based on the vertical line test. The other part of our new stuff today is talking about domain and range, and that was in our vocabulary part. For the domain and range, we're talking about what the x's can be and what the y's can be. If I give you a graph like I have in number 5, the domain, I'm just going to use a D for domain and an R for range. In something like this is just 6 points. I can just write down what all the x values are and what all the y values are. So for this ordered pair right here, that point is at 0, 4. The x number, the domain number is 0. The y number is 4. This point is at 1, 4, so I could have a 1. I don't have to rewrite the 4. And this point is at 2 with that same 4. When I move on to this one, that's at 3, 3. So 3 for the domain number and 3 for the range number. 4, 3, 4, but I already have the 3 for the range, and 5, 3. When they're individual points, you get individual numbers. When I have something like this that's called a continuous or a connected graph, I can't possibly list all of the x's and all of the y's. We use what's called a compound inequality for this. When I'm trying to decide what the domain is, let's just start with that. I want to know what x's are being used. So the lowest that this gets for my x's is -3. And then the highest that this gets is +3. And all of my x's are in between that. Now I want you to think about what we've done with inequalities. All of the x's are in between these two. The x is bigger than or equal to -3 because it's going to the right of -3. Notice how the alligator is trying to eat the x. But all of the x, all of the stuff that's graphed, is less than or equal to +3. That's how we write a compound inequality. This is just saying the x's are in between -3 and +3. The range is what the y's can be. The lowest that this gets is right here. Remember, this is going to be all about y's. Big hint, always going to be less than on both sides of the variables. The lowest that it gets is 0. The tallest that it gets is right here, which is at 3. So, in these last couple of problems, I want to get the domain and the range. I want you to notice that this is an open circle. It's not being used. So even if I start with my x and I have my less thans on both sides, it's not going to be equal to on one side, but it will be equal to on the other side. The farthest to the left that it goes is at -5. And the farthest to the right that it goes is 0. For the range, again, start with my less thans, the lowest that it gets is at -4. And that is a filled in circle, so that's an equal. The tallest that it gets is 5. Okay, now I know that we've got a couple other problems on here that I'm going to skip in the video, but the worksheet today is going to look like these kind of problems. So would you please today make sure that you're doing that worksheet. One side is about, is it a function or is it not a function? And then is it, what's the domain, what's the range? The answer keys in Schoology. Please use that because I know that those could be a little bit tricky, but then there is going to be a learning check in Schoology as well. Let me know if you need any help.